Good morning, everyone. Thank you to SAMAC for inviting me. Yes, I'm talking about pollination and the buzz, a little bit about honeybees, but mostly about pollination. Mostly about cross-pollination. So historically, is that main slide down? Can we make that full side or not? Doesn't matter. Thank you. So historically, macadamias have been viewed as partially self-pollinating or partially self-compatible, or even historically, if you look in the old literature, typically it said they were fully self-pollinating and that they didn't need cross-pollination like you would find in a pear orchard like that, where you actually have cross-pollinizers or pollinizers interplanted in the orchards. And therefore, in South Africa and everywhere else in the world, historically, macadamias have been planted in big solid blocks, single cultivars. That is changing, slowly changing, or changing probably quite quickly, but still the majority of macadamias are planted in solid blocks. And equally, partly because they were viewed as self-pollinating, but also partly because there was an historical view that wind pollination was significant, and also because macadamias are attractive to insects. There historically has always been a view that you do not need commercial pollination for macadamias, the historical view, and for the most part, commercial pollination, paid pollination, moving bees into macadamias is a new thing. And still, most parts in the world, commercial pollination does not happen. People do not pay for paid pollination in macadamias, and honeybee colonies that you find in macadamias mostly are there for honey production, and it's only in recent times that they are there for paid pollination. And as we've seen throughout this conference, and it's quite remarkable the growth that's happening, this has not stopped macadamias growing. It's not stopped it in South Africa. The fact that it's mostly solid blocks, the fact that there's no limited amount of bees in pollination, macadamia is growing through the roof and continues to grow seemingly. But the question needs to be asked, is it optimal? Is this the best practice that you could have? Is it sustainable? What should we, should we be re-looking at cross-pollination? And today, that's what I'm going to do. Cross-pollination data, there's data on the value of cross-pollination from as far back as sort of 1959, 1960. Lots of data in the 1990s, data in the early 2000s in South Africa. So maybe it's time that we actually re-look at the pollination data. So today, I'm going to be looking at some results in South Africa, recent results that I've done for SAMAC and some other stuff, but also focus a lot on recent data from Australia. The questions that I'm going to ask, basically, what are the different options that you can, the different ways that you can look at cross-pollination research? Come to a general conclusion then in terms of how important is cross-pollination in macadamias, and some discussion about the variability between cultivars in terms of their need for cross-pollination as regards self-pollination. Some discussion on the overall benefits and the potential of cross-pollination, and then I'll also make some brief comments about orchard design and also about pollination deficits, and at the end a little bit about pollinators and honeybees as well. So in terms of studying cross-pollination in macadamias, there's three basic methods that you can follow. You can do what I call the scoping method, or that's by inspection or by inference. And that's just literally looking at a farm, looking at your current farm, and actually making predictions of what you would get in that farm relative to the position of other cultivars. So you can actually have a look at a block. So if you have a block of solid cultivar A and solid cultivar B, you would expect that the interface between there, you would have, if cross-pollination is important, you would find where the two blocks are next to each other, you would find a better pollination or higher set or higher production in comparison to the other side of the block if there was just two cultivars, the same cultivars planted together, or in the middle of the block. So it's basically just literally looking at what you have on the ground, making clear and obvious predictions as to what you would expect if pollination is important, and actually assessing that situation. Then you can do controlled pollination, controlled hand pollination, which is basically taking trees and then you actually close racemes with bags and you hand pollinate them with whatever you want to hand pollinate them with and see what happens. And then there is more modern techniques, which is basically doing a genetic analysis of the nuts that are present, the nuts, all the seedlings, what is being produced, and you actually work out who's your daddy, and you work out who the pollinator was, and then you can actually work back from that. So I'll touch on all of those. The scoping project by inference, that's the easiest and the cheapest and the most accessible to a grower because you can do it yourself. Potentially also, I have a soft spot for it because I think it's almost the most accurate for each individual. You can work out what your current situation is and what your current demands or potentials are. It tells you exactly what's happening on your own farm. And as I said, you basically look at your orchard design. This is where I started when I dipped my toe in Max for the first time in 2017. In a farm in Barberton, in SAMAC farm in Barberton, and we just looked at big solid blocks of Beaumonts, and on the one side, so you have 3 solid blocks of Beaumonts together, and then on the sides of them you had 816s and 814s, and you could actually have a look if you look between 2 blocks of Beaumonts, what you get compared to on the 816 side of the Beaumont, and moving forward from there. And in terms of that basic scoping data, and let me highlight that this is data that was collected by the grower themselves. I just marked the trees, highlighted the trees. These are the trees. Look at these 12 trees compared to these 12 trees compared to these 12 trees, and you actually collect the data yourself, and you work out what you're getting in the middle of the block compared to the outside of the block compared to the side that's close to the pollinizers. And in that study, in Beaumonts, if you had a look at the pollinizer side, it was 51% higher than the non-pollinizer side. And the outside of the block, the pollinizer side of the block compared to the middle of the block, it was about a 70% difference. In 816s, the differences were about 35%. And when we actually looked at mixed blocks with 814s and 816s planted together, we could find no such gaps or no such differences inside. So clearly on that farm, very clear and obvious pollinizer differences, pollinizer deficits, and that pollinizers and pollinators were making a big difference in terms of what the production was in the different parts of that farm. There's another study, Skalk Skuman and Mark Penter. This goes back to 2007, published in the SAMAC journal. This is doing pretty much exactly the same thing, but in a bit more detail. And that data is looking at Beaumonts as they move away from a 788 pollinator. And as you can see, as you go row by row away from the cross-pollinizer, the production decreases. But again, that's basically scoping data, simply just measuring production in a row as you move away from the pollinizer, and you can work out what the importance of cross-pollination on your own farm is. Hand pollination, historically, many studies done on this. You basically, as I say, you actually take a raceme, you close it up, you open it to hand pollinate it with whatever you want, and you close it up again, and you see what happens. You also keep certain bags permanently closed so you see what happens with no pollination, and you also have other racemes that you leave open, fully open, so you get your open pollination as a control. And there's been many studies done on this. USA, Hawaii, Australia, and recently South Africa, and pretty much across the board they've shown a value of cross-pollination, but they also show highly variable results. And I've done 2 substantial studies for SAMAC in 2019 and 2021. In 2019, we just used 5 cultivars, 816s, 814s, 695s, A4s, and A16s. And it was sort of a preliminary study. We only had 14 trees per cultivar. We used organza bags to close them up, and we hand-pollinated them with transparencies with pill vials, and we measured the final nut set, basically what was produced in each of those different crosses, those different cross-pollination sets. And then the 2021 result is an extension of that. Now we use 12 cultivars, but because the cultivars fly at different times, and also because you actually literally logistically can't pollinate 12 by 12, we divided them up into an early cluster and to a late cluster, 6 of each. So the early 6 cross-pollinated with each other, the late cluster pollinated with each other. We did it a bit of a different method this time. We didn't use transparencies, we used whole racemes to pollinate them. And again, we measured the final nut set. I should also mention all those nuts that were produced in all those combinations, the 6x6 and the 6x6, they have all been harvested and they are all available, and they are currently being analyzed for size and kernel weight and quality by Mark Penta at ARC TSC, and potentially there's a lot more information that can come out of those combinations. So your basic results, I'm not going to go into too much detail with the results. In the 2019 study, if you look at cross-pollination versus open pollination, so the combined cross-pollination compared to what the average in the orchards was, it was increased by about 52%, and in 2021, cross-pollination increased production across the 12 cultivars by 79%. And if you look at the cross-pollination average, again, across all the cultivars, cross-pollination against self-pollination, in 2021 it was 156% better, and in a much smaller sample size in 2019 it was almost 600% better. And the devil is all in the details, so there are the data for the 2021 things. Those data are available from SAMAC. SAMAC have that data. I think a lot of people have the data already. And that will give you, for each of those 2 clusters, which were the best donors, which were the best, and for which ones was cross-pollination most important. I'm not going to pause too much on that. Those are the early clusters, and there's the late clusters. Of course, the ones that are highlighted are the self-pollination figures for each of those 12 cultivars. And sort of summarizing it, I've put the 12 cultivars together, and moving from the left to the right. The left are the ones that really need cross-pollination, moving to the right, the ones that seem to set with a lot of self-pollination. So A16s seem to be setting perfectly happily by themselves, 741s, NELMAX. And on the other end, A203s, 842s, A268s, 814s, all needed a cross-pollination much more than the other cultivars. I would hesitate at the moment, or I'll put a cautionary note here. This is one block. These are one farm for each one, limited sample sizes. I don't think you're going to get massive differences with other cultivar. I mean, repeating this in other areas, but I personally wouldn't bet my whole farm on doing this without doing some repeats and some validation of a lot of these results, because I do think you will get some variation. Moving on to the third study, the genetic paternity one, which has largely been done in Australia, though there is some stuff coming here, which is basically the same idea as the scoping project. Here you just actually look at a block and you harvest nuts or seedlings from around it, and then you work out where, who is pollinating what, who the daddies are, and for each of those cultivars you can work out you get that type of data for each cultivar, who the parents were. This This data lends itself to looking at really big solid blocks, like this is data from Stephen Truman in 2022. So you can look at really big solid blocks, 180 meters, or even more than that, 410 meters, I think those big blocks are. And you can see inside that middle of the block compared to the outside of the block, what differences are you getting with cross-pollination? In narrower blocks, what is the impact of cross-pollination or self-pollination in narrow blocks compared to big large blocks? Or you can actually look at mixed blocks, and you can actually see, okay, so in the center of the mixed block, which parents are delivering the pollen, which you can work back to say, okay, this is how pollination is happening within this block. It's been transferred hundreds of meters or 20 meters, and you can actually try and unravel how the pollination is actually happening. The bottom line for all these genetic paternity studies, summarized through about 6 or 7 current papers, very recent papers, from, as I said, from Australia, pretty much wherever you look, whatever data you look at, 80 to 90% of all nuts are cross-pollinated. Even in blocks where you're in the middle, as I say, these very large blocks, solid cultivar blocks, 24 rows in, 180 meters in, still 80 to 90% of all nuts being produced in those blocks are cross-pollinated. And this last figure, this is unpublished data, very given to us. So we have to thank Stephen Truman from Australia. And there's also data coming from South Africa, Mark Penter, involved in this. And this is looking at all their different cultivars, the relative proportion of self-pollination versus cross-pollination. And you do get variability. You get some cultivars, as we've already seen, where self-pollination is quite important. But largely across the board, all through their cultivars, it's cross-pollination is dominant, and in many of the cultivars, it's almost 100%. What these data do show, though, is there seems to be some anomalies. There's an 816 there in South Africa and an 816 in Australia that deliver very different results. Quite what that says, we're going to have to actually dig down and work out what it actually means. Again, I would put my little disclaimer in: don't bet your farm on this until there's better data on all of it. What it does show, though, is overwhelmingly cross-pollination is the major factor that's happening in reality on farms with almost all cultivars. So Xenia effect, all those data, everything I've presented to you so far is all about nut set. Xenia effect is the effect of the genotype of pollen on fruit or nuts. And in macadamias, it doesn't actually only stop with nut set. The different pollen, the different daddy that you might use impacts on the kernel weight, also on the kernel quality. And there's a whole lot of data coming out, papers coming out literally every quarter now, showing that fatty acid composition, mineral composition is dictated, not dictated, but impacted by the different pollen donors. So you actually have got the spectre happening literally now that you almost can create designer nuts. If you want to have a nut with a particularly high palmitoleic acid or high magnesium, etc., and you are farming with cultivar A, to deliver the best in that regard, you need cultivar X to be pollinating it, whatever that situation is. Again, still lots of data to be delivered for that to be possible, but quite clearly the different pollen donors, the daddies, have a significant effect on what ends up in your nuts. Overall, we're going to find that we're going to get clusters of cultivars, because the cultivars that are quite close to each other, quite closely related to each other, tend to actually not do too well with cross-pollination. So we fundamentally need to know what the relatedness between all the cultivars are. And all those types of data are available. and the genetics are available. We have the capacity in South Africa at FABI to actually do all these genetic analysis, and it's one of the first steps that we need to do to unravel all of this is to just work out exactly what the relatedness between all the cultivars are. At the end of the day, orchard design, theoretically we can design orchards, we can design farms where you can actually decide exactly what's going to be in your nuts, like you would decide what's in your wine, and you can actually limit it so you can have only one cross-pollinizer, so you have only nuts of one particular design, almost like they do when they do crossbreeding of onion seeds and other things. You have isolated areas where you limit whatever other pollinizers are available. It'd be quite difficult in an open system, but it's definitely possible, but there are currently a lot of information gaps. Fundamentally, we need to understand how this cross-pollination is happening in these massive single cultivar blocks. It's not happening from bees flying from a pollinizer tree to another, to your cultivar. So most of the cross-pollination is taking place inside the hives as in-hive pollen transfer, and we need to actually work out exactly how that's working and how that is actually being responsible for this massive degree of cross-pollination. And then also we just actually have to do a lot of work on why self-pollination in various cultivars is much less than in other cultivars, and that's all going to be something to do with pollen growth inhibitions and pollen inhibitions, which limit self-pollination. So all those types of information are needed, and then we'll be able to theoretically design your optimum orchard, delivering the nuts that you particularly want to deliver. Last comments. Pollination deficits and pollinators. We all know that macadamias produce a huge amount of flowers, that nut set is sort of 0.5% or even lower, 0.3%. And if I'm saying now cross-pollination is so valuable, you ask the question, what is possible then? If you cross-pollinate whole trees, if you literally were able to make sure that every nut, every raceme is cross-pollinated, how big can you go? And fortunately, there's been a little work done here as well, but Stephen Truman in Australia has published data, and the end result is you can only actually increase your production around about 30%. If you literally hand-pollinate a whole tree, and you compare it to trees that are getting good open pollination, you can only increase your production around about 30%. That's the physiological limit of that tree. That's how much you can actually increase it. So when people talk about pollination deficit, that's what we're talking about. That's what you're talking about in terms of what currently occurs by insect pollination compared to what could be delivered if you literally hand-pollinated every raceme in that tree. In South Africa, I think our pollination deficit is a bit higher. My 2021 data suggests it's around about 78% at maximum, but perhaps a bit less than that. That possibly reflects that we don't have as good pollination in South Africa compared to the case in Australia. In Australia, they've got naturally adapted stingless bees that actually are very happy on macadamias. We don't have such things in South Africa. Our pollinators are honeybees, and basically honeybees alone. Different data sets that we have already shows that it's 99% plus of all pollinators on macadamias are honeybees. And we will need to work with honeybee management and design our operating strategies better, use more bees to actually close that gap. Certainly we can from what I've seen, we can certainly reduce that pollination deficit down to at least the 30% or so that they get in Australia. So conclusions, cross-pollination critically important in some cultivars, only very important in other cultivars. It's absolutely fundamental to all your breeding and planting strategies. 75,000 hectares in the ground. It would have been good to know which are the best to plant next to each other before now, but for later cultivars, for new plantings, and for mitigation of existing solid blocks, we need to know which are the best the best combinations. Inadequate and variable crop pollination, crop production is at least partially due to non-optimal, suboptimal pollination. And likewise, cross-pollination doesn't happen by itself. It will require bees, and in South Africa, honeybees are pretty much your only option, and macadamia industry is fundamentally dependent on a viable and healthy beekeeping industry. Questions raised, I've discussed these all, so I'm not going to go through them. We need to work out what are the best cultivar combinations. We need to investigate the anomalies that we're seeing in South Africa and in Australian data. We need to actually look at what exactly are the specific benefits of each combination, and then you can make your choices in terms of your designer nuts. Is November drop all self-pollination? Probably. Be good to confirm that. We need to actually work out what the relatedness of all the South African cultivars are. There's a lot of potential in hive pollen transfer. We need to confirm how important it is, and then we have to see how we can enhance it. And we need to determine, as I said, the mechanisms of self-pollination, inhibition mechanisms, etc. And at the end of the day, we end up with best orchard design. Thanks to SAMAC for their support and for their funding for this project. A huge, huge thanks to Kudu Farms for helping, for doing, allowing all the cross-pollination work this year and making it possible. Also to FOSMAC for all their help. Thanks to Kobus Visser and Bee Naked Honey for beekeeping support, and to my colleagues, my colleague Mark Penter, and to Stephen Truman in Australia. Thank you very much, ladies and gentlemen.
Questions for Mike? One.
Hi, Mike. I'd just like to know, you mentioned an increase of 50% on the, I think it was Beaumont or something like that. What are the actual yields? So on your control compared to, let's call it your trial, what were the yields on that? So I mean, if you, are you telling me that if I get or a person gets a 6-ton yield, but if I've got a cross-pollinator next door, I'm going to get 9 tons per hectare?
Within those specific blocks, I'm not absolutely certain, but potentially, if you're looking at within that situation, that data there, you have to say if you can get the best production that you're getting in the different trees in the whole block, if you could get that in all those trees, then yes, you would get up to 9 tons. I don't know what the maximum would be. The maximums would be very much determined by all kinds of different factors, but all of this is just relative to other areas in that block. Are you getting the best production that you can get?
Thanks, Mike. And then another question. You were speaking about pollinizers. If we could find out what the right pollinizer is for, let's say 816, and go and harvest that pollen, and then lay it up in the front of the hive for the bees to do the work. Have you done something like it? Is it possible?
It's a bit more complicated, but that type of thing happens with other crops. There's people that do in-hive pollen transfers and in-hive pollen development stuff in pears, in plums, etc. It is possible. There's all kinds of factors involved. You have to know what your germination rates are, how the viability rates, how well they store, whether you can keep them for a whole year, etc. And it's quite technical to get bees to actually to put it into beehives. You can't just put it outside; they won't touch it. You can put it in a dish outside; they won't do it. But yes, it is absolutely practical. It's absolutely possible. It's possible to have a block of, what you were saying, A16s or whatever, and have that be your only block, nothing else, not a single other macadamia cultivar within macadamia tree within 10 kilometers, and that you've bought your pollen, which you have chosen to be 788s or whatever, and it's stored in your fridge, and you put it into beehives and they deliver it. theoretically possible, absolutely.
Just wanted to ask, would better pollination equal better crackouts? For instance, would you be able to lift a Beaumont's crackout percentage with a couple of percentage points?
So in this respect, I would have to ask Mark Penta, etc. But in terms of the data that's coming out, yes. Better cross-pollination results in bigger nuts and better crack-out potential and better kernel weights. I know nothing about macadamias.